Hello, boys and girls. This is Mr. Newman, and today we are going to go over Weekly Review 2.6. So make sure that you have the right weekly review. I want you to go over this with me and then tell me how many you missed. Some of you, especially if you're in Group A, you don't have your Weekly Review 2.6 with you because you guys turned it in here at school, but you can always find it in Canvas, what you turned in. You can find it in Canvas, your digital copy. So I do want you to go over this with me and tell me how many you missed at the end of this video. All right, here we go. So remember, this is Weekly Review 2.6. Make sure you have the right Weekly Review 2.6. All right, number one, Olivia drives 46 miles to work and 46 miles back home from work each day. How many miles does Olivia drive to and from work if she works for 7 days? Write an equation using M to represent the unknown and solve. So I'm going to write an equation for this. In order to find out how many miles she drives to and from work each day, I have to add 46 plus 46, or I'm going to actually do 46 times 2. A little bit of a shortcut. So I'm going to do that part first. And then I'm going to repeat this 7 times because she works we're trying to figure out how many she works for 7 days. 7 days. So and that will be equal to M, how many miles she drives in 7 days. All right, so this is a multi-step equation. We have to do this part first and then multiply by 7. So 46 times 2. So I'm just going to come over here and solve 46 times 2. And I'm going to use the standard algorithm of multiplication. And that's 92. 92. So that's 92 times 7 equals M. And now I'm just going to do 92 times 7 using the standard algorithm. 7, 6, 44. So it looks like M is going to be equal to 644 miles. And I do want to put that unit of measurement. That's very important, miles. So 644 miles. Number 2, which expression can be used to find the product of 1,407 and 8? What does product mean? Product means the answer to a multiplication problem. So there are multiple answers here because it says which expression. So there's more than one answer that could work. So here it looks like they took 1,407. They used expanded form, and they're going to multiply all that by 8. This is called the distributive property. So 8 times 1,000, 8 times 400, 8 times 7. So that would work. That would be a true answer. Here they actually show the distributive property in each of the values in 1,407. So we have 1,000 times 8 plus 400 times 8 plus 7 times 8. That would also work. So let's look at this one. C says 100 times 8, 40 times 8, 7 times 8, and all these added up. Well, this looks good, and this should be 400 times 8, and this should be 1,000 times 8. So these two are wrong. If you go back and look at the problem, it's not 100. This is not 100, that's 1,000. And this is not 40, it's 400. So C would not work. Look at D. Here they've kind of put all these in one. 8 times 407, which you could definitely do. And then 8 times 1,000. It's going to be the same problem as A and the same problem as B. This is just a little shortened version. So that would also work. So A, B, and D, there are 3 answers to that. A, B, and D are all true answers. All right, number 3, fill in the box with the answer. So it doesn't really matter what strategy you want to do with division. I'm going to come do the standard algorithm of division. So whatever strategy that you want to use, make sure you show your work and then put your answer in the box. So I'm going to use the standard algorithm of division. Okay, can 9 go into 5? 9 can't go into 5, so I'm not going to have an answer in the hundreds place. Can 9 go into 51? Yes, 9 can fit into 51. How many times? 9 times 5 is 45. 9 times 6 is 54. That's too big, so it looks like it's going to be 5. 5 times 9, 45. I subtract that, and I get 6. Then I'm going to bring down the 3. 9 can go into 63 exactly 7 times. 7 times 9 is 63. Subtract, and I don't have any remainder. So the answer here is just 57. I could check that if I wanted to. 57 times 9, so your quotient, your answer, times your divisor should equal your dividend if you get it right. 9 times 7 is 63. 9 times 5 is 45. Plus 6 would be 51, which would be 510, plus that 3, 513. So you know you got that right. It's a good way to verify your answer. Number 4, round 238,367 to the nearest thousand and to the nearest 10,000. So you have to round it twice. So I'll do 1,000 and then 10,000. So I have to round it two ways. So 1,000. So the thousands place would be right there. The 3, I look at the digit right behind the thousands place. It's the hundreds place. The 3 would make the 8 round down, so it stays at an 8. Everything in front stays the same. Everything behind the 8 would go to a 0. So this would be 238,000. All right. And then let's round this to the 10,000s place. I'm going to underline the 3, circle the digit behind it. It's an 8. So the 8 in the thousands place is going to make the 3 in the 10,000s place round up to a 4. So it'll be 240,000. Everything behind it goes to a 0. There we go. So the thousands place, 238,000. 10,000s place, 240,000. Rounded it two different ways. All right, number 5. Natasha is making necklaces. She has 34 centimeters of string. Each necklace needs 7 centimeters of string. How much string will be left over after she makes all the necklaces she can? So here we want to use the remainder. How much is going to be left over after she uses all of the string to make necklaces? So we have 34 centimeters of string being divided into 7 because that's how much it takes to make a necklace. I'm just going to write an equation here. I'm going to solve this. This time I'm going to use a different strategy. I'm going to use an area model with division. I can easily do that. So that would be 34 divided by 7 equals n. That's kind of how I write this with an area model with division. Remember, length times width equals area. I know the length. I don't know the width, so I have to divide the area by the length to get width. So I'm going to break this down into something a little easier to work with. So I'm going to break my area model down into, let's see, what's my largest multiple of 7 without going over 37? So 7 times 5 is 35. That's what I'll use. I'll use 35. 7 times 5 is 35. How much is going to be left over? Well, that's going to be a little box of just 2 left over because 7 can't go into, let me make that a little neater. 7 can't go into 2, so that's going to be my remainder. There we go. Man, I can't make that 2 like I want to. There we go. So my quotient is 5, remainder 2. Everybody see how I did this area model? I just broke 37 down into 35 plus 2. Why did I choose 35? Because that's the largest multiple of 7 that I could use to go into 37. 7 can't fit into 37 evenly, so that's why I used 35 and 2. That still makes 37. 5 or 7 can go into 35 5 times with 2 left over. So it looks like n is going to be equal to 5 with 2 left over, 5 remainder 2. To answer my question, how much string will be left over, it would be 2 centimeters of string left over. 2 centimeters left over. that would answer that question. And you didn't have to use a area model to solve this. I just like using different strategies. So this is a good strategy to use because you only have a 2-digit dividend there, just a 2-digit dividend. Very easy strategy to use as an area model. All right, number 6, select all the composite numbers. Now, composite numbers are numbers that have more than 2 factors, So you can do T-charts with all these, but I know every even number except for 2 will always be composite. So I'm going to circle all the even numbers that aren't 2. That's all the even numbers. I know that 15 is composite because of 5 times 3 and 1 times 15. And the rest of these will be prime. 5 is prime, 29 is prime, and 31 is prime. Okay? So 4 is composite because of 2 times 2 and 1 times 4. 15 is composite because 1 times 15, 3 times 5. 26 is composite because 1 times 26 and 2 times 13. So composite, composite, composite. All right, guys, that's the end of the first page. Okay, guys, this is page 2 of the weekly review. This comes from lesson 27 in Zern, lesson 27 in mission 3. So I'm not going to do all these just to save some time. They're all pretty similar questions. I'm just going to do one. I'm going to do letter B, 755 divided by 5. I'm going to use place value dis, and I'm going to use the standard algorithm to solve this. So I'm going to draw a place value chart. All I need to do is go to the hundreds place. So we have the hundreds, we have the tens, and we have the ones place. So just a very simple place value chart. Doesn't have to be too fancy. So the hundreds place, the tens place, and the ones place. So I'm going to show 755 in dis. So 1, 2, 3, 4, 5, 6, 7. And then there's 700, and then 5 tens, 1, 2, 3, 4, 5 tens, which is 50, and then 5 ones, 1, 2, 3, 4, 5. Now, since I'm dividing by 5, that's my divisor, I'm going to group things in sets of 5. Anything that I can't group in 5, I'm going to drag to a smaller place value and then make 10 of those because, for example, I'm going to grab 500. I group that. That's one group of 100. And these two I can't group. I don't have 5 to group together because I can't divide those evenly by 5, not in the hundreds place. So I'm going to drag these over to the tens place to see if I can group them counting by tens. And if I take 100 and move it to the tens place, that becomes 10 tens. 100 is 10 tens. So I've got to take these 2 hundreds and make 20 tens. And that's exactly what I'm going to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I got to do that same thing again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 20. So now I'm going to see if I can group my tens place in sets of 5. So I can definitely group some here. 1, 2, 3, 4, and 5. It worked out perfectly. Nothing left over to drag to the ones place. And then I'm going to group my ones place in sets of 5. So 1, 2, 3, 4, 5. I can grab these right here, and I'm not going to have anything left over, no remainders. So it looks like I have one group. Let me change the color here. I have one group of 100. I have 1, 2, 3, 4, 5 groups of tens. And I have one group of ones. So it looks like my quotient, my answer is 151. Now let's check this using the standard algorithm. 755 divided by 5. Blank, blank, blank. Can 5 go into 7? Yes, it can go one time. I'm going to multiply 1 times 5 is 5. Subtract that from the 7, and I get 2. Good answer. Now I'm going to bring down the 5 next to my 2. Now the problem is 25 divided by 5. 25 divided by 5 is 5. I put that in the tens place, and I multiply. 5 times 5 is 25. I subtract. I get 0. Then I bring down my last digit here, which is a 5. This is 5 divided by 5. 5 divided by 5 is 1. I put that above in the ones column. 1 times 5 is 5. I subtract and I get no remainder. 151, 151. Same answer, shown two different ways. This is a very basic way, place value disk, very basic way to show division. And this is a good way to check it. So if you get the same answer, you probably got it right. That's the only problem I'm going to do just to save a little bit of time. These are all going to look pretty similar, so just check these and see if you got the same answer on both sides. Chances are, if you got the same answer, you did it right. All right, on to the third page. Okay, third page of the weekly review looks like this. It says find the quotient. So we have, that means find the answer to a division problem, the quotient. I use that word a lot. 3,752 divided by 6. Let's work that out. 3,752. I'm going to use the standard algorithm here since I have a 4-digit divisor. Why did I write 2? 6. So blank, 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 blank. 6 can't go into 3, so I'm not going to have an answer in the thousands place. And that's good because none of my answers are in the thousands place. 6 can go into 37 6 times. So 6 times 6 is 36. I subtract that from 37 and I get 1. That means it's a good, you picked a good number in the hundreds place. Anytime I subtract, I always have to get an answer less than the divisor. It's got to be less than the divisor. Now I'm going to bring down the 5 next to the 1. 6 can go into 15. 2 times. 2 times 6 is 12. I subtract that. I get 3. 3 is less than 6. Good answer. Now I'm going to bring down my last digit, which is a 2. 32 is not a multiple of 6, so I know I'm going to get a remainder here. 32 divided by 6, that would be 5. 5 times 6 is 30. Make that a little neater. 30. And I subtract, and I get 2, nothing else to bring down, so that is my remainder. 625, remainder 2. There you go, D. You can always check that by multiplying 625 by 6, and then add the 2 at the end. You should get 3,752. So that's the answer to number 1, D. Number 2. Carter has a pack of 800 rubber bands. Alicia has twice as many rubber bands as Carter. They combine the rubber bands so they can make bracelets. Each bracelet needs 100 rubber bands. Which equation below is used to find how many bracelets they make? Well, if Carter has a pack, I'm just going to do it over here. Carter has a pack of 800, and Alicia has twice that number. So I'll just say C. Alicia has twice that. So she has 800 and then 800 again. 800. She has 2 packs of 800 rubber bands. So if they put all those rubber bands together, how many 800s is that? Well, that's 3 groups of 800. So I know I'm going to have to multiply 800 times 3 or add 800 3 times. Which equation shows that? It looks like the only one is B. 800 times 3. Then they're going to divide all the rubber bands by 100 because that's how much each bracelet takes to make 100 rubber bands to make a bracelet. So they're going to divide all those by 100, and that's the last step of this equation. A lot of people I saw last week pick A, 800 times 2. Well, 800 times 2 would just be Alicia. That would not even be adding Carter's if they combine them back together. So this is Carter, and then Alicia has double of what Carter has. So she has 1,600. Plus 800, that would be 3 groups of 800, which would be 2,400, 2,400 total bracelets, or rubber bands, excuse me. So the correct answer is B. John chose A. Well, you probably know why John chose A. He did not add together Alicia's and Carter's, or he just took Carter's and he just said Carter times 2, 800 times 2. He just doubled Carter's, but then he forgot to come back and add Carter's and Alicia's together. That would be 800 times 3. So as long as you wrote an explanation there, I mean, there's really no way we can figure out exactly why John chose A because we are not John. We can only make a good guess. And I'm assuming John probably chose A because he did not add Alicia and himself, or excuse me, he did not add Alicia and Carter together. That's probably why he chose A. All right, number 3, I'm going to do rather quickly. I believe it goes false, false, true, and false. There's only one true with this. You just got to work these out. I believe this one has a remainder and D has a remainder. If they don't put the remainder in the answer, guys, you can't. It's definitely not true. It can't be true. It can't be true if they don't include the remainder and you solve it and you get a remainder. B is one you could definitely do by estimation. If I round this to 80 and kind of work backwards, 80 times 6. That would be 480. That's not even close to this. This is missing a whole value. This should be at least an answer in the hundreds place. So I know B is definitely false. And then C is true, and then D is almost true, but you do get a remainder with this, I remember. So just to do this quickly, it goes false, false, true, false. C is the only one that's true. You just got to work those out. D is really the only one that I would recommend. You can do this one mentally just by estimating. All right, on to the last page. 2 questions here, or 3 questions here. Chloe and Ingrid are packing boxes with books. They have 238 books. Each box will fit 8 books. Chloe says 29 boxes is enough to pack all the books, but Ingrid thinks that's 30 boxes. Explain who's correct. Well, I'm going to divide this in C. 238 divided by 8 equals, I'll just say B for boxes. I'm going to use the standard algorithm to solve this. I'm just going to do it over here. 238 divided by 8. All right, blank, blank, blank. Can 8 go into 2? Nope, so I'm not going to have an answer in the hundreds place. Can 8 go into 23? Yes, it can go twice. 2 times 8 is 16. I subtract, I get 7. I'm going to bring down the 8. 78 divided by 8. 78 divided by, that'd be 9. 9 times 8 is 72. I subtract, I get 6. Nothing else to bring down, so I have a remainder. 29 remainder 6. Now I'm going to have to use this remainder somehow because this is a word problem and I can't use remainders with word problems. So what this means is 29 full boxes it will take to pack all these books, but I have this guy left over, a remainder. I have 6 books left over that is not in a box. So how many boxes would it take to pack all of the books? Remember, I have 6 books left over. 29 full boxes of books, 29 equal groups, but I have 6 books that aren't in a box. So how many boxes would I need, or how many boxes would they need to pack all of the books? All of the books. So who's correct? Is it Chloe with 29 or Ingrid with 30? It's Ingrid. Ingrid is correct because you need an extra box here. 29 boxes is not enough because you have 29 boxes is not enough because you have 6 books left over that haven't been placed in a box. If you have to put all the books in boxes, then that means you have to get an extra box for these 6 books because you can fit 8 books in a box. You only have 6 books left over. Get an extra box. Ingrid. 30 boxes. That's how many you need, not 29. This is where you have to interpret that remainder. So we just had to add 1. We had to add 1 box to our answer. We had to add 1 to 29. That's how I got 30 boxes. Ingrid is correct. Ingrid. Caroline has 1,090 photos that she wants to organize into an album. Each album holds 6 photos. How many pages can she fill with 6 photos each? So we're going to divide 1,090 divided by 6. So 1,090 divided by 6. And I'm just going to say P for photos. Let's solve that. I'll go over here and solve it. 1,090 divided by 6. I'm going to use the standard algorithm of division. Blank, 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 blank. So 6 can't go into 1. 6 can go into 10 one time. I subtract that from 10. I get 4. I'm going to bring down the 9 next to the 4. 49 divided by 6. That would be 7. 7 times 6 is 42. I subtract and I get 7. So look what I did. This is a good example of what happens when you don't pick a big enough number in your quotient. 7 times 6 is 42. and I subtracted, I got 7. But 7's bigger than my divisor, so I didn't pick a big enough number here. I got to go back and pick a higher number. Glad I picked up on that mistake before I finished the whole problem. So I can go bigger than 7. I can actually go 8. 8 times 6 is 48. Yeah, that's much better, and I get 1 left over. So that is definitely smaller than 6. Bring down my last digit, which is a 0. 6 can go into 10 one time. 1 times 6 is 6. I subtract, I get remainder 4. 4 left over. So 181 full pages with 4 photos left over. What is my answer? Well, my answer here is just going to be 181 full pages. Full pages. I can't add 1 to my answer this time because it only wants full pages. How many can she fill? 181 fill pages. It's full pages. F-U-L-L, full pages. There we go. So if you have this remainder 4, that means you have 4 photos left. So you can't fill a page with 4 photos. It takes 6 photos to fill a page. So that's why I couldn't say 182 full pages, because that wouldn't be true. I can only fill 181 full pages, not 182. If the question was different and it said, how many pages would it take to put all the photos in the album, then the answer would be 182, because you'd have to put these extra 4 over here, these extra 4 pages onto a new page. But since it only wants full pages, you just have to ignore the remainder. We can't use it in this problem. It all depends on what the problem says. All right, last one, number 6. Excuse me. Number 6, in 4 weeks, a school raised $2,560 for health fitness awareness. Students collected donations 5 days a week. The principal agreed to make one donation that was the same as the amount collected in a day, in 1 day. If an equal amount was collected each day, how much did the principal donate? Well, this is a multi-step problem. The first thing I have to do is figure out how much they made in a week, and then figure out how much they made in a day. So in 4 weeks, this is the amount they make. So I have to do 2,560 divided by 4 is going to equal how much they made in a week, in 1 week, because this is how much they made in 4 weeks. So I got to do this first. I need some room to solve this. I'm going to do it over here. 2,560 divided by 4. All right, blank, 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 blank. 4 can't go into 2, so I'm not going to have an answer in the thousands place. 4 can go into 25. Let's see, 6 times? Yeah, 6 times 4 is 24. I subtract, get 1, bring down the 6. How many times can 4 go into 16? 4 times. 4 times 4 is exactly 16. I subtract. I get 0. I got to bring down the next digit, which is a 0. Now, I have to have a place value. I have to have something. I have to have the digit here. I can't just leave that alone. 4 can go into 0 times. I got to put a digit there. I have to have a place value holder there. I can't just leave it blank. So I put a 0 there and then finish out the problem, no remainder. So $640 in a week. So then I take 640, that's how much they made in a week, and then I have to figure out how much they made in a day. If they only collected money 5 days a week, I have to divide that answer by 5. This is going to tell me how much they made in a day, and that's what the principal agrees to donate, is how much they make in 1 day, in a day. So 640 divided by 5 now. So I'm going to come down here and solve that. 640 divided by 5. You should know this should come out evenly because 5 can go into numbers that end in 5 or end in 0. So this should work out evenly. Blank, blank, blank. 5 can go into 6 one time. 1 times 5 is 5. I subtract that from 6. I get 1. Good answer. Bring down the 4. 14 divided by 5 would be 2. 2 times, I don't like that 2. There we go. 2 times 5 would be 10. I subtract, I get 4. That's less than 5. That's good. I'm going to bring down the 0 next to the 4. 40 divided by 5, that'd be 8. 8 times 5 is 40. I subtract that and get no remainder. So my solution, here it is. If the students collected $128 in one day, then that's how much the principal is going to donate, $128. This was not an easy problem. You really have to understand the steps and the order to do them in to figure out how much the students made in one day, and then that's how much the principal is going to donate. All right, guys, that's your weekly review 2.6. A lot of great questions in there. Hope you guys watch it. Have a great weekend. See you on Monday. See you. Bye.